Hello guys, welcome to our YouTube channel. So today I'm going to explain our PRML course project Music Genre Classification. So let's start it by explaining and visualizing our data. We have downloaded Getzen dataset from Cargill. The link is provided in the description. So let's start with our project. These are some libraries which we have used. First we'll mount the Google Drive. So let's start exploring our dataset. This code loads a dataset from a CSV file, summarizes its contents and then explore the folders or files within the specific directory. This code imports necessary libraries for audio processing, loads an audio file, and print information about audio files such as the audio waveform, sample rate, and length of the audio file. This code calculates the tempo of audio signals, which represent the speed and pace of the music measured in beta per minute. This code creates a box plot to visualize the distribution of tempo (BPM) across the different genera in the dataset and saves the plot as the image file. Graph box plot displays the distribution of tempo (BPM) across different genera. The box plot will have boxes representing the interquartile range (IQR) for each genera. The line inside each box represents the median tempo for the respective genera. This code generates a scatter plot to visualize the data points after performing PCA with different marks represents the different labels or genera and saves the plot as an image file. In this PCA graph, we can see the scattering plot displays the distribution of data samples in a two-dimensional space defined by the principal components obtained from PCA. We observe clusters of groups of points that are close together. These clusters indicate similarities and patterns among data samples. Points that are more spread out contributes more to the variability in the dataset. Coming to the main classifiers used are Decision Tree Classifier, Adaboost classifier, New Bayes classifier, Logistic Regression classifier, KNN classifier. Now let's discuss each one of them in the details. Decision Tree Classifier, some libraries which we have used in Decision Tree Classifier. This code performs an executive search over a specific hyperparameter grid to find the best parameter for the Decision Tree Classifier using cross-validation. The optimal parameters are determined based on the performance of the classifier on the training data. This code provides information about the best parameter and their associated mean in cross-validation score, which indicate the performance of the decision tree classifier with the optimal hyperparameters on the training data. This code evaluates the performance of the best estimator on the test set using cross-validation and prints the accuracy score for each folds as well as the mean accuracy score. Second classifier is Adaboost classifier. This code performs hyperparameter tuning of a Adaboost classifier using grid search, cross-validation and print the best hyperparameters and their corresponding best scores. This code evaluates the performance of the best estimator on the test set using cross-validation and print the accuracy score for each fold as well as the mean accuracy score. The third classifier, New Bayes classifier. These are some libraries which we have used. This code trains a Gaussian New Bayes classifier, performs cross-validation on the test set and prints the cross-validation score along with the accuracy mean score. To the fourth classifier, Logistic Regression classifier. This code initializes a logistic regression module with specified hyperparameter for tuning. The hyperparameters are chosen to control regulation and optimize the module performance. This code performs grid search cross-validation to find the best combination of hyperparameters for the specified module. Using the provided parameters grid, it prints out the best parameters and the corresponding best cross-validation score. This code evaluates the performance of the best module obtained with search on the test set using cross-validation and prints out the cross-validation score and the mean accuracy score. Now we'll go to the fifth classifier, KNN classifier. This code assesses the performance of a KNN classifier of the test set using classification report, which includes precision, recall, F1 score and support for each classes, and confusion matrix, which shows the counts of true positive, true negative, false positive and false negative. It also calculates mean cross-validation score for the KNN module. Result comparison. This code creates a visual comparison of the best score and mean score for different classifiers, providing insight into the relative performance. The bar chart usually compares the performance of different classifiers based on the best and mean score. Each classifier has two bars. First represent best score obtained from grid search CSV, other represent mean score obtained from cross-validation. Best score is colored with light blue, mean score is colored with light coral. Highest best score and a mean score are generally preferred as better preference. Lower bar suggests poor preference. The above bar chart provide a clear comparison between the best and mean score for different algorithms. Finally, from the above graph, we conclude that Adaboost is the best for the selected data among the 5 classifiers. The link of the project is given below in the description block. Thank you for watching this video.